In this lesson, we're going to solve equations with rational exponents. Up until this time, we've had polynomial equations that have exponents that are natural numbers, and we've had radical equations, which technically did have a rational exponent. If you remember, the square root is equivalent to the base raised to the 1/2 power. So here, in order to solve this equation, we want to first isolate the power. So you can see is that we're really looking at this similar to how we used our square root property. We want to get that x to the 2/3 by itself. So we want to isolate the power x to the m over n, or it might be a quantity of x plus or minus a number raised to that rational exponent of m over n. So I'm going to move the 18 over first. So we have 6x to the 2/3 equals 18, and then dividing both sides by 6 would be left with x to the 2/3 equals 3. Now at this point, in order to solve for x, we need to raise both sides to the reciprocal exponent n over m in order to get x completely by itself. Now there's two major notes that go along with this, is that if m in the original rational exponential equation is even, we're actually going to have two solutions. We would have x equals plus or minus the number raised to the n over m. So let's look at what we have right now. Right now we have x to the 2/3. And x to the 2/3, if we were to write this out using radical notation, we would have the cube root of x to the 2nd power. Well, remember that in order to solve this, if I was doing it piece by piece, technically in order to solve an equation of this form, so I'll even make it still equal to 3, in order to solve an equation with a radical, we would first raise both sides to the 3rd power in this case, and then our next step we would have x squared equals 3 to the 3rd, 3 to the 3rd would be 27, then our next step would be to get rid of the square. In order to get rid of the square, we would be taking the square root of both sides, which gets to really the point where we would have the square root of x squared equals some number, I'll just say k for right now. And then we said, all right, well the square root of x squared is really the absolute value of x equals k, or more commonly, x equals plus or minus k. So the fact that we have an even exponent to start with, right, that numerator m is even, means that we're going to have two solutions. So we'd have to have x equals plus or minus the number raised to the n over m once we raise it to the reciprocal exponent. The second note would be that if m is odd, we would just have one answer, so we would just have x equals the number, let's just say k, raised to the n over m. So it makes a difference whether m is even in the original rational exponent of our original equation. So with that in mind, let's apply the second step using that note. So first, I'm going to be raising both sides to the reciprocal exponent. So that means I'm going to be raising both sides to the 3/2 power. So both sides. So on the left-hand side, we know that our exponents would end up canceling out, so that we're just left with x. On the right-hand side, though, this is where the important part comes in, is that we raise both sides to the reciprocal exponent, but the original numerator of our fractional rational exponent was 2. So since 2 is even, that means that x on its own really equals plus or minus 3 to the 3/2 power. Okay, so the fact that we started off with a 2 in the numerator 2/3 2 means that we're going to have an x equals plus or minus here. Our next step would just be to simplify what we have. So I would have x equals plus or minus, so 3 to the 3/2 would be the square root of 3 to the 3rd. So 3 to the 3rd would be 27. So we have x equals plus or minus the square root of 27. And then simplifying this radical, we would have plus or minus square root of 9 square root of 3, or really just x equals plus or minus 3 square root of 3. Last, just like we had with solving our radical equations, we do want to check. Here I would strongly suggest that you use your calculator because we're dealing with rational exponents and radicals, so it can get a little hairy. So first we have two solutions, x equals 3 square root of 3, and then x equals negative 3 square root of 3. So if I substitute in 3 square root of 3, we always go back to the original equation. So we'd have 6 3 square root of 3 raised to the 2/3 power minus 18 equals 0. And like I said, I would strongly suggest you use your calculator. So you could enter this in then as 6 parenthesis 3 square root of 3. Just be careful if your calculator opened the parenthesis for the square root, you do need to close it. Close the parenthesis. Use your caret raised to that fractional exponent you do need to put in parentheses. So parentheses 2 divided by 3, close the parentheses, minus 18. And it should equal 0. So we should end up with 0 equals 0. Same idea then for your negative 3 square root of 3. I would have 6 negative 3 square root of 3 raised to the 2/3 power minus 18 equals 0. So then from here, same thing, typing it into your calculator, you would have 6 parentheses negative 3 square root of 3. Just make sure the negative is attached to the 3 inside the parentheses, raised to the 2/3, 2 divided by 3 minus 18. And again, hopefully you should get that 0 does end up equaling 0. So our solution set then would just be 3 square root of 3 and negative 3 square root of 3.